Welcome to NASA Edge.
An inside and outside look
at all things NASA.
Hey, today we have a great show because we're going to be talking about the total solar eclipse.
A phenomenon which hasn't occurred in the United States, well, the contiguous United States, since 1979.
And this next total solar eclipse is going to take place on August 21st, 2017, and we're going to actually be there for a live show in Carbondale, Illinois.
Yeah, I can't wait. You know, that path to totality is going to swing just south of Portland, Oregon. It's going to sweep through Casper, Wyoming, go just south of St. Louis, through Bowling Green, Kentucky, and to Charleston, South Carolina. It's going to be awesome because millions of people from around the world are going to be coming to the United States.
And not to see us, but to see the total solar eclipse.
That's right. Yeah, it's crazy. Well, actually, I haven't seen a total solar eclipse since the opening of Heroes.
You got me, because I was going to say, when did you see a total solar eclipse?
I want some superpowers. Hopefully with this eclipse, we can pick up some superpowers.
Maybe.
I tell you what, we have a lot of subject matter experts on the show today. Going to be talking about eclipses in general, where are the best sites to see the eclipse, and we're going to talk a little bit about where we're going to be and about our show.
But to get things started, I talked to Eric Christian at the Goddard Space Flight Center, and he gave me the 411 on what a total solar eclipse is and why it's so important to us. So Eric, tell us exactly what is a total solar eclipse?
So a total solar eclipse is when the moon moves between the Earth and the sun so that it completely blocks the light from the surface of the sun. And at that time, the Earth gets dark, you're in the shadow of the moon, and you can see the atmosphere of the sun, which normally you can't see, called the corona, streaming away from the sun. It's a really neat, in the middle of the day, you're seeing it dusk to dark on the ground. The animals react. It's just a really amazing situation.
Now, Eric, how common is it for someone in the United States to actually view a total solar eclipse?
So a total eclipse happens somewhere on the Earth at most twice a year. Most years only get one because of timing of where the moon is in its orbit. But somewhere on the planet, on the average of once a year, you get a total solar eclipse. But the shadow of the moon is actually pretty small. And so if you're just standing at one point on the Earth waiting for a total solar eclipse, it can be hundreds of years between when a total solar eclipse will happen. What's really neat about the 2017 solar eclipse is that even though the shadow is small, it goes right across the heart of the United States, from Oregon through south of St. Louis, all the way to South Carolina. And so even though it's only going to be a small part of the United States that sees the total solar eclipse, everyone in the United States is going to get at least a partial solar eclipse, and anyone who wants to can easily travel to the path of totality, to this line that the shadow takes across the United States.
What is the path of totality?
So the path of totality, there's a large region where the moon will only partially block the sun. We call that a partial solar eclipse. The region where the moon completely blocks the sun is pretty small, and that region moves at better than 1,000 miles an hour across the United States. So that's called the path of totality. That's where the path of the shadow of the moon moves as the total solar eclipse happens.
So Eric, there are satellites in space that study the sun. Why is it important for us to do it from the ground here on Earth?
So there's a couple reasons why. We have what are called coronagraphs, which make an artificial solar eclipse by putting a disk out in front of a telescope and camera to block the main light of the sun so you can see the corona, the atmosphere of the sun streaming away from the sun. We've been flying those for many years in space, but because for various physics reasons, because the disk is so close to the telescope, you can't get all the way down to the surface of the sun. You have to start further out. You have to block more than just the sun in order to see the corona. With a total solar eclipse, the moon is almost perfectly the size of the sun, and so you see the corona almost all the way down to the surface of the sun. And that's actually that narrow region that you can see in a total solar eclipse that you can't see from space, is where all the action is happening. That's where the solar wind is accelerated. That's where the corona is heated. And so that's really exciting to see that deep corona in a total solar eclipse from the Earth that you can't see from space. The other thing that's useful about a total solar eclipse on the Earth is that it's a great way to test instruments that are studying the solar corona without the expense of launching them into space. And so you can actually point at the solar corona look at it during the total solar eclipse. You've only got a couple minutes, and so it's a real rush job. But during those eclipses, you can test an instrument in a way that you can't until so you get a much better instrument that you can launch.
Now, scientists have been studying eclipses for forever. And what different information do they collect when they see an eclipse one year after the other?
So the sun is always changing. The sun is a variable star, and so that corona changes with time. The corona is millions of degrees, much hotter than the surface of the sun. And normally when you get further away from a heat source, you get colder. So the question of why the corona is so hot is one of the big scientific questions we have about the sun, and solar eclipses can help us with that.
Now, we just can't look up into the sky with our bare eyes. We need some protection. Tell us a little bit about what we need to actually view the solar eclipse.
So during the total solar eclipse, when the moon completely blocks the main light of the sun and you see the corona, you actually don't need glasses. That's one of the neat things about it. But any other time during partial solar eclipses, during things called annular solar eclipses, and during planetary transits, Mercury and Venus transits, you need to protect your eyes. You'll really hurt your retina if you just stare at the sun. Even if only a sliver of it, the sun is so bright that it only takes a teeny sliver to do some damage. So even though it may look dim because most of the sun is blocked, you still need glasses. And there'll be millions of these things across the United States, and you should put on your protective glasses, and then you'll still be able to see the sun. These things are completely black to everything except the really bright light, but you'll still be able to see the sun. You'll be able to see the crescent shape during the partial eclipse, and you'll be able to see annular eclipses with glasses like these. So you gotta protect your eyes.
Now keep in mind, to view a solar eclipse, you have to wear eye protection. So these sun viewing glasses is a great way to see the partial eclipse before totality and after totality.
And you can also use a number 14 Waters glass like I'm wearing right now to view the eclipse.
Or you can kick back on the Star Killer base and watch through a mask just like this one.
Well, you really can't use a mask like that, Blair.
Yeah, the Kylo Ren mask is not going to work.
No, just because it's dark around the eyes doesn't mean it's going to be safe. You're going to have a welder's glass or
these type of glasses, a pinhole demonstration. I mean, just regular sunglasses is not going to cut it.
I wonder if I have a receipt for this mask.
Save it for Halloween.
Great idea, Chris. Fortunately, I had the opportunity to speak with Mr. Eclipse himself, Fred Espenek, who has safely seen many, many eclipses. Let's check it out.
So, Fred, do you mind if I call you Mr. Eclipse?
Not at all.
So, how many eclipses do you think you've seen in your lifetime?
In terms of total eclipses, I've been to 27 now. Wow. And I've seen probably about 3/4 of them.
Is that because of weather or?
Yeah, clouds. You can predict exactly where the eclipse is going to be to within a fraction of a second, but predicting the weather is a bigger challenge. And sometimes the luck of the draw, you get bad weather.
Now, in terms of a total eclipse, I know what that is, a total solar eclipse. What are the other kinds of eclipses that you've seen and studied over the years?
Well, the most common eclipse is a partial eclipse, in which the moon only covers part of the sun's disk. Those are interesting. They're sort of something to do in between total eclipses. Another solar eclipse type is the annular eclipse. And in some ways, it's similar to a total eclipse in that you've got the moon passing directly between you and the sun. But on the other hand, it's like a partial eclipse because not all of the sun is covered during an annular eclipse. The moon appears smaller than the sun, and you're left with a ring or annulus of sunlight surrounding the moon during the maximum phase. And the disadvantage of that is that you don't get the darkness of totality, you don't get to see the solar corona, you don't see planets in the daytime. So it's really, as far as viewing it, it's much more like seeing a partial eclipse.
Now, with all these eclipses that you've seen, a few have been in the United States, but a lot of these are happening in maybe some more remote places around the world. What's the most remote location you've gone to see a solar eclipse?
Hands down, Antarctica.
Wow.
Was on a Russian icebreaker for 28 days. We pulled off onto the ice sheet on eclipse day and set up on the ice sheet. Unfortunately, we had a lot of mixed cloud that day, so we saw bits and pieces of totality through some clouds. So it wasn't the best experience from that point of view, but the change in the lighting, we were surrounded by these icebergs, and the change of the lighting, the colors on the icebergs was fabulous.
Now, We're going to be at Carbondale, obviously, for the 2017 eclipse. And what I'm wondering is, I know that that's a unique situation because 7 years later, Carbondale again is going to be right on the path of totality. How frequent of an occurrence is that kind of intersection when it comes to eclipses?
Well, the frequency of seeing a total solar eclipse from any one spot on the Earth is about once in 375 years. It varies a lot over that number. That's just a really average number. But to have two of them in the same place is astronomically unusual. The previous total eclipse that passed through Illinois was back in 1869, so over a century ago.
Wow.
And in the future, the next total eclipse in Illinois is 2153, so that's over 100 years into the future before we get another one here.
Just from my limited experience, I've never seen a total solar eclipse, but from my mind, it seems like they would all be the same. What makes the solar eclipses different each time?
Every solar eclipse is different. For one thing, because they happen all over the world, you're in a different country. You're experiencing a different culture, a different environment. It might happen at a different time of day. The duration of the eclipse is different from one eclipse to another. It might be 30 seconds in India, and it might be 7 minutes in Mexico. But the real major difference is that the sun's corona is very dynamic. It changes day to day, hour to hour. I mean, you look at the NASA SOHO images in the LASCO coronagraph, and you see the corona really dynamic over the time scales of each image that are taken. So imagine the difference in the corona from one eclipse to another that's separated by 18 months. They're enormously different.
What is it about the eclipse that has sort of directed your life, this life goal of chasing them all around the globe? What is it about them that interests you the most?
Well, there's sort of two, at least for me, there are sort of two aspects of it. One is the sort of intellectual satisfaction of being able to predict something with such precision and then see it come to fruition. But the other one is much more visceral. It's just the primal reaction of seeing the sun vanish in the daytime sky and replaced by this eerie twilight and the outflashing of the sun's solar corona, which is just the most spectacular, beautiful, natural phenomenon I have ever seen with the naked eye. It's just incredible. And no photograph, no video comes close to actually seeing it with your own eyes.
Blair, while you were doing the interview with Fred, I was just actually hanging on every word. And I have to say, he's probably one of the most interesting interviews we've ever had on NASA Edge.
Yeah, and I'm just thinking about the preparation that goes into an event like this. I mean, because of weather,
right.
He's got to be ready to go out to the West Coast and be ready to view the eclipse there, Carbondale, or even on the East Coast, and make that decision at the last moment so that he can continue his reign as Mr. Eclipse.
I tell you what, that is sort of the big X factor in viewing a total solar eclipse is going to be the weather.
Yep.
I mean, you have to, a lot of these eclipse chasers are on point the day or two before. They don't know where they're going.
It's true.
So.
We're going to be locked into Carbondale, Illinois, but I'm actually wondering if he actually has his own private jet so he can hop around and get to where he needs to be.
If he doesn't, it's a good call.
Think he has Mr. Eclipse on the side?
Maybe.
And speaking of being locked in, being in Carbondale at Southern Illinois University, Bob Baer, who is the co-chair of the Eclipse Steering Committee, gave us an invitation to actually come out and do the show there. And we were out there a couple months ago to check out the facilities, and we're looking for a big show there. And I had a chance to sit down with Bob and learn all about the activities that are going to go on. So Bob, you're one of many cities along the path of totality that's going to be covering the eclipse. What is Southern Illinois University going to be bringing to the table?
So quite a bit. This is a really large area here in Southern Illinois, and the university is about 6 to 7 miles from the point of greatest duration. We're setting up a lot of different venues here. We've got venues that will be open to the public leading up to and the day of the eclipse. We're going to try to enhance people's experience when they come here.
Now, we're expecting millions of people, not just in the United States, but from around the world to be flocking along the path of totality, from Oregon all the way down to Charleston. How are you going to deal with all these crowds coming to Carbondale?
That's a really good question. So what we've been doing in our planning is we've been planning for what we think we can handle on campus. We're working with the city. The city's doing some of their own planning as well, but we're trying to tie it together so that it works well. But give the people who are coming here a place to go, let them, in some cases, reserve tickets for some of the venues so that they know that they have a spot. We're working with the hotels through the area, and as well as with the state property, the parks, the state forests, the national forests. There's a lot of people from those organizations today to take part in planning.
Are you going to offer programs for your students to be able to do any scientific research with the eclipse next year?
The main one here is the Citizen Kate experiment.
Okay.
And that one, as you can see, we have one of the telescopes here today from that. We got involved in that a couple years ago while it was still being formed somewhat. I was working with Matt Penn, who's the PI of that project, and I went with one student from SIU to Indonesia. I went with a physics undergraduate named Sarah Kovac.
Okay.
And Sarah's leading a good-sized group of students here. They'll be doing a workshop here at this conference tomorrow and continuing this through this eclipse as well as beyond, we hope.
Now, you were over in Indonesia to view the last eclipse, which was back in March of this year?
March 9th, 2016, yep.
So what are some tips that you can give to the general public who may want to see the eclipse, or if they're outside the path of totality to see the partial eclipse, that may help them out?
So the eclipse is big. That was one of the things I didn't understand. When I saw it in the sky, it was a lot larger than I expected. You've got this full moon and you've got a corona, and that corona looked to be about twice the diameter of the sun. So you don't need a telescope to see that. You can see a full moon naked eye, and you can see that corona naked eye, and that's the only way you can see the corona. There's a sunset effect that you get 360 degrees around you, so if you have some open space anywhere around you, you can see that sunset. If you have a lot of open space, if you're up on a high elevation, the sunset's all around you. And that sunset, those colors fade in and fade out. For people who are nature lovers, you've got all these cool sounds coming in, like the frogs, the crickets, all the animals that come awake at night come awake during an eclipse. And it gets pretty loud. In Indonesia, that got very loud where we were at. We had tropical birds just going crazy around us. And then depending on the place you're in, like for Carbondale, we're gonna have the crowds here. I'm really excited to see this with a large amount of people, to hear the roar of the crowd, to see the reactions of the people. The partials, eclipse glasses are great, projection methods are great, and as you get close to totality, those high percentage partials, like say a 90% partial, when that light comes down through the trees or through a hole, like a pinhole, or even you can hold out your hands and you can see the diffraction patterns on the ground. You can see little shapes of the eclipse on the ground as you get to 90% and above. Wow. So there's lots of cool things kids can do during the partial as long as they're supervised. If I had some advice for people who are going to take pictures of the partials with proper filters. That's great. That's a lot of fun. You've got like an hour to do that in. But once totality hits, you really need to be looking at totality and just enjoying it.
Once you have totality and that moon is blocking the disk of the sun, you can pull those glasses off and see the corona.
In fact, you have to, right? Because if you're still wearing the glasses,
that's right.
You won't be able to see anything.
But then that's where the time comes in, because I think for us in Southern Illinois, I think it's like 2 minutes and 40 seconds for totality. But once you approach that 2:40, you got to put those glasses back on, because once you see the sun again, I mean, it could damage your eyes.
Yeah, it's very important. And what's also interesting, in addition to all these events